here is the first firing up of the Steampunk Regen. I've got the glass battery. I've got two cells with a dropping resistor for the filament, about 1.5 volts. I don't know if you can hear it in the headphones. It's picking up CHU pretty nice at 7850. So time to put the receiver all back together, and I can say I'm fairly satisfied with the way that the Steampunk Scotty Regen came out. I also focus a little bit on the plug-in coils. I go through the coils that were built back in the 30s, and I even attempt a coil on my own. This is my first coil that I've manufactured for the Scotty Regen. So we'll go through that whole process, including how to pot the tube base. So here it is. We're finally up to part 6, the final video in this series in restoring the receiver. I do want to take the receiver out for a camping trip, and I'm looking at different locations to take it out portable and maybe do a civilian conservation corps camp that is close by, and that would be period correct for a simple ham station used at a CCC camp during the 1930s. So the radio really does a beautiful job on 75 and 80 meters. Band spread's good.
KB1, DX. Yeah, okay. And a beautiful signal down here. Yeah, I'll be right over with, I don't know if you know, probably KW1I Dale and the guys. So I'm up back of if you're coming up the big hill there.
Now, I have been using this small battery-powered amplifier with the receiver. It's kind of like my LM386. If you can hear things well with that amplifier, you can hear things well with headphones. So that's the way I'm allowing you guys to hear what's going on. Several people have built this circuit now using the 1U5 wired as a triode, driving the 3V4 output, and it runs on a little 1.5 volt AA cell to light up the filaments, and pretty much anything you put into it from 20 volts to 60 volts, and it's very happy and makes plenty of audio.
And of course Ted parks up there in the commercial building with this clinic.
Now, another thing I didn't mention, I'm using 50 ohm antennas and bringing it into this high impedance circuit through the trimmer capacitor as a coupling control. That's really a mismatch right out of the box. This radio is made to be used with a long wire antenna with that trimmer control. Now, it does work. One big fault of the receiver is not having a coupling control on the front. I wouldn't be able to beat that unless I drilled a hole and mounted a insulated trimmer. Now, how satisfied was I with the receiver? I can say that there's probably 5 different things that I would do differently on this receiver if I was to modify it. However, in general, it does as advertised. It even works quite well up on 20 meters. This is 20 meters. And it does an admirable job on single sideband, which really surprised me. So the 40 meter coil, it's in Autodyne. But it does not have the fidelity of a fine AM regenerative receiver. The other thing that kind of bothered me was that the coupling control is a simple trimmer, and you can't get at it with the unit assembled. You need access through the top cover to tighten or loosen the coupling with the trimmer capacitor. So those are some things that I found a little bit annoying. I like the idea that it's limited to small band segments. But that made making the plug-in coils much more difficult because you didn't have a band set capacitor that was very forgiving. You had to be within a couple or 3 turns to hit the band properly using the tube-based plug-in coil system. Working beautifully now. This is smooth, nice and smooth. This is nice and smooth. Cleaned up this knob a little bit and got it set correctly. And the majority of the wiring is completed. A few more wires to go and this thing will be ready to go. Now, the way it sits right here, I believe it can be fired up. This takes the place of the rheostat. I've got the 2 wires that go to the rheostat shorted together. Also, remember how the rheostat was grounded in the original circuit. Now that we have the rheostat in series with the A battery, it has to be lifted off ground, so an insulating system has to occur here because naturally a rheostat's wiper is grounded through the shaft. So you do have to insulate this before putting it back. The next step, after it's completely wired, is you do a complete buzz out using a meter. You buzz out all the grounds with a beeper, and then you go in with the ohm meter and you measure the circuit and go right against the schematic. And I like to use a marker that shows what I've checked, and once the schematic is checked against the wiring, only then do we begin to apply power and try to get this thing to fire up. So there actually is a standard for plug-in coils, 4-prong plug-in coils, where we have a single tickler and a single grid coil. And here it is. You guys are familiar with this probably from the boys' first book of radio and electronics, and most of the coils that you could buy from the mail order houses followed this pattern. This is not that. This has its own special, we'll call it a very special pinout. And in the higher bands, you're able to fit the tickler above the grid coil. And in the lower bands, you're resorting to nesting a tickler inside the coil and then potting the whole thing. So this is our starting point with the plug-in coils. So I've got the Steampunk Regen with the antenna disconnected, but I have a lead going to the high performance receiver. We're just looking at the performance on 14 megahertz. But not bad for 1920s technology on 20 meters. Just getting it going, and I decided to try the 20 meter coil. I wanted to see if I had enough feedback. Got about 35 volts on the plate, and the regen control is about halfway up. So it looks like with the plates fully meshed in the regen, I can go as low as 11.5 megahertz. Looks like I can just hit it. That's unmeshed on the band set capacitor and about halfway. So I can actually go higher. I wonder if I can hear WWV. Let's try it. I had a coil that was actually in my junk box with the green winding on it, and it's absolutely perfect for 40 meters on this set. The tickler and the main coil are reversed, but they're both reversed properly. So the regen doesn't know any better. But it's picking up with the set capacitor right in the center and the main capacitor towards the bottom. I got the bottom of 40 meters. Anyway, this coil works very well for 40. So this is the mystery coil. This did not come with the set. And this is 40 meters. We got the tickler on top and the main tuning down below. And that's a very nice wind for 40. Now let's compare that to the 40 meter wind. And you will see that the tickler coil on the one that came with the set is way overdone. Not only is it closer space, but it has too many turns. So this is the 40 meter coil that was designed for the set. It is working. And I actually like the position of the band set capacitor even better. It's more capacitance. But I can't take it out of autodyne. It's got way too much tickler. And eventually it goes crazy if you increase the voltage enough. So that's way too much tickler on that coil. So I'm going to remove some turns on that 40 meter coil. This will settle that down. It's even worse once we're at full voltage. I'm at 40 volts. If I go up to 45 volts, I can't do anything. Can't do anything. Tickler much too big. This is the 80 meter coil, picking up weather facts, 4 megahertz weather facts. But I had to turn the voltage down to 30 volts, and I still can't get out of autodyne. Not much I can do about this one though, because the tickler coil is inside the coil. Okay, this plug-in coil I tried for 80 only goes as low as 4.4. So, that guy's a miss. It does cover 5 megahertz easily though. Okay, so this guy covers 4.4 to 6, and it says 80 meters off. Yeah, that's for sure. That explains why he made 380 meters. I think he missed. Keep building coils. Let's try another 80 meter. See if we can hit the band. This third 80 meter coil's hitting the 49 meter band right in the middle. So he's too high. So let's go up further. And we'll try... looks like this guy will go as high as maybe 6.8. And that guy, he needed more voltage, and the regen turned way up. So his tickler was off as well. So you got two things you got to get right here. You have to hit the frequency with the amount of coupling you've got available with your trimmer, and you got to be able to get enough regeneration with the tickler coil buried deep inside the coil. So I'm pretty satisfied with the 40 meter coil and even the 20 meter coil. He tried 3 times to make a decent 80 meter coil. You know, this one here I think is the acceptable one. It's a little bit hot. It has a little too much regeneration, and of course the tickler coil is inside, so there's not much we can do here. So I'm thinking of trying to do a better 80 meter coil. So I've cleaned out this base, removed the cement from the tube base, and basically you can hit that with the heat gun and then just go in there with something sharp like a small screwdriver and get most of it out, and hitting it with some sandpaper inside. I'm going to try to make a 80 meter coil in this tight package. Now notice that he has some tube bases here that are larger. Isn't this interesting? And just that amount more might make a big difference. But I'm going to have to do what he did. I'm going to have to nest the tickler coil inside. But let's see how to do this. This is a process I've never seen before. I'm going to try to emulate what he did and end up with something that actually gets me in the middle of the band with the band set capacitor somewhat towards the bottom. For the best band spread, you'd like to have this capacitor around here. Not here, not here, and not fully meshed, but someplace around there that gives you a little bit of wiggle room. Maybe let you get down to CHU, but right about there, That allows the best band spread because you've got most of the capacitor engaged, and it's going to make the tuning easier. Now the base had a key, a bayonet key on it that helps you to put the tube in the right orientation. That has to be removed. I didn't do a great job at it, but it has to be removed so you can put the winding on. So there's a couple ways I could go. I mean, I could attempt to put the 30 turns or so on the outside using enameled wire. A little bit closer wind should fit on there, no problem. It's very close as it is. Or I could take a pill bottle, which wants to go in here anyway almost, and just shove it right in there and make a conventional plug-in coil with a tickler top and bottom. But of course I want to do it the hard way like he did. I want to nest a tickler inside, and then I want to fill it with some kind of goop and see what we can accomplish. Okay, not the prettiest thing in the world, but you guys get the idea. I've got a plastic insert that's going to be the tickler coil, and I have the outer, which is going to be the secondary or the grid coil. I actually have three kinds of wire I could wind this coil with. I have the period correct solid wire, cotton covered. This old spool would give me the exact match to what they were using in the 1930s. I have some modern Litz wire, a little bit thicker in diameter, but not much. Looks just about identical. I could try that. And then I have ordinary enameled wire of different sizes. Again, we need to hit frequency. So I'm going to start with this regular wire and see if I can get there. Let's see if I can get the requisite 29 or 30 turns on the tube base, and we'll see if we can hit 80 meters. The maximum spacing on the coil, I came up with an angular shot so I could get right to the bottom edge, popped out right at the pin on the bottom side for the secondary grid tuning wind. This is going to loop back down and go straight down into the pin. So we're going to make a J-hook. We're going to go straight down into the pin and then pull it tight. The loop has been made, and I've soldered it into the pin. It's snug. Now we just pull, and there it is. Now we're going to start the wind. And we'll be winding basically through the Antenna Engineering Handbook around page 200 should give the correct tension for the wind. So here's the original coil. It's got 30 turns on it. And here's my coil. Now my coil has wire that's a little bit finer. And I've also got 30 turns. So let's see how close I come to the 30 turns with a little bit heavier wire. So I've got a sharp needle, sometimes called a bodkin, that I've heated up with a soldering iron, and it's simply punching right through the polystyrene. Okay, I've gone in and out with the wire on the bottom. Now we're going to start winding. So I'm going to make both ends long enough that I can swap them real quick to make sure the tickler is in phase. So I am winding in the same direction and starting on the bottom, just as I did with the other coil. So I'm being consistent that way. So I realize that 30 turns on the nested tickler coil is probably going to be way too much. But you know what? I'd rather start high than low. So let's put this tickler coil in, see if we can get the mutual coupling sense correct for positive feedback. And then we'll see if we got too much feedback and start to reduce turns. It is oscillating. I did have the tickler on backwards, of course, to start with. But with the tickler reversed, it's oscillating at about 13 volts. So we have way too much tickler. And as you can see, to hit 3.3 megahertz, the capacitor is just about 3/4 open. So we have much more inductance than with the other coil. But in any case, we know we need to take turns off. So I'm going to start by taking off probably about 5 turns. And let's see, 5 turns have been taken off. Let's see if we can hit 3.3 at the bottom of this thing. Nope. That's about where it would be acceptable to be 80 meters, the bottom of 80 meters at 3.5. So we need to take some more turns off. Now I don't want to go too far because there's another variable here, and that's the tickler coil itself. Remember, we have to take turns off the tickler coil too. How will taking turns off the tickler coil influence my resonant frequency range? Okay, I went 2 turns too many. I can hit 3358. I can't hit 333. So we have our answer. Probably should have kept, instead of taking 5 off that second time, I should have only taken off 2, maybe 3. Okay, I've taken 5 turns off the tickler. Notice how one lead is longer than the other? That's how to get things started when you're going in blind. First get one pin started, then the other. So I'm down to about 12 turns on the tickler, and I could say that we're getting close. It's now easily going into regeneration at 25 volts, and I would rather have it go in more towards the center of the regen dial at 35 volts or 45 volts. So we still have too much feedback. It's pretty apparent that a nested tickler has a lot more coupling than when you're spaced 1/4 inch out. So I started with a little over 30 turns and I'm down to 10 now. I think this is going to be the one I want. 10 turns, and I've taken 10 turns also off this coil. Okay, I think we're there. The 10 turns did it. At 45 volts, I'm able to go right into regeneration, no problem. And if I go down to 30 volts, I can still do it. So that gives me the range I'm looking for. Now I took 2 turns too many off the coil. It's still hitting 3.5 megahertz, no problem. But I lost my ability to tune CHU. Will it work better on 80 meters? Probably, because I'm using almost all of the bandset capacitor, and that means that the band spread will be maximized. But I went too far. Now, once I load this with some kind of potting compound, I expect the frequency to go down. So I think that might actually help me. So the next step is, what can we put inside this coil that won't destroy it? For the coil, we're going to be using hot glue to attempt to pot this coil. I may use the heat gun so that the hot glue settles in properly. Let me do some preheating with my heat gun. Okay, I've got my hot gun here. And let's start the gooping process. Looks like the polystyrene is going to give me some trouble, but we'll see. This is a really hot gun, by the way. This is not a toy. Okay, let's let that settle. Give this one more little heat treatment with the gun. You can see the level is going down on that, so it's definitely taking the hot glue. Let's let that settle. We'll see what we got. Okay, the coil's put in and it's cooled off somewhat. I put the fan on it for a few minutes. Looks like the frequency has changed. I would say it's probably going to go down in frequency. Okay, yeah, it did go down. Not a lot, but it did go down in frequency a little bit. Let's try the low end again. 3.33 megahertz, sorry about that. 3.285. Again, it went down a little bit. Not bad, not much reaction. I put a lot of hot glue in there, and it did not change the frequency markedly. Also, the regeneration seems normal. So this may destroy the coil completely, but you know I had to do it. I had to completely pot it just to see what would happen. We like to experiment here on the Microwave 1 channel. Now, if I had to do this again, I would not use the high temperature glue sticks. Okay? This is really high quality, high temp stuff. I would not use the high temp. I'd use the low temperature gun and the low temperature glue sticks. Now, using a polystyrene form for the tickler coil was a mistake. You would instead want to use something that can handle the heat, like ceramic, fiberglass, any number of plastics could probably take this heat, but certainly polystyrene did not like the heat of the high temperature glue gun. The frequencies actually come up a little bit. This is on the full potting. That seems like it's really going to be fairly inert. The entire thing is now potted. And here's the top of the band with the potting completed. Next, I'm going to put the polyurethane on the outside of the coil. Not too bad. The finished product just has to be tested now. It's somewhat dry. The polyurethane is on the outside. Okay, some lowering of frequency with the polyurethane on the windings themselves. Frequency went down again a little bit. And on the low end, you can see it went down a little bit on the low end as well. But pretty stable. So I'm very happy with the results on the coil. And I did go back and I tacked on that turn that I took off, about a turn and a half I put back on. And now this frequency range is a result. This does the 80 meter band perfectly. Between 30 and 45 volts, I have good regeneration with the primitive potentiometer regen control. So I hope you've enjoyed this 6-part series on restoring the regenerative receiver that was built in the early 30s. It was interesting to do the restoration and to learn about the circuit and what the original builder was thinking. It does have its faults. I wish it had better coupling on the input because it's easily overloaded compared to a regenerative receiver that has good trimmer or coupling control. I will say that the batteries fit inside as designed. You can get 5 9-volt batteries, 2 D cells, and 2 either triple or double A's as your C battery easily inside the package. It all went back together with no trouble, and it has excellent audio output on headphones. Plenty of volume. Of course, no volume control, and you handle that with the regeneration control. Sometimes increasing the regeneration to reduce volume when you're doing CW or sideband, or reducing the regeneration when you're in AM to lower the volume.